Okay, hello guys. Today we are going to talk about the hypothesis testing. We are going to test some hypotheses and know which one to use as the hypothesis. As we know, in our daily life, we often meet our expectation or assumption. We somehow make assumption on our girlfriend, on our boyfriend, on our mom, our father, or our siblings. Perhaps we often make assumption like, did my girlfriend is chatting with another boyfriend, or maybe did my girlfriend is having a video call with other boy or whatsoever. That is our assumption. And assumption in academically, we often call it as the hypothesis. Hypothesis is somehow can you call assumption in daily life. So now we are going to test our hypothesis by eliminating another hypothesis, so we can use the hypothesis that we will choose later. So now I will explain you by an illustration. Imagine you have 4 siblings. This is probably you, and this is your other sibling. 1, 2, 3, 4. And imagine your mom say to you, to your sibling, to wash the dishes every day. So you and your sibling decide to wash the dishes every night. And the way you pick who will wash the dishes at the night is that you put your names into a bowl and randomly pick it up. You put your names into a bowl and you randomly pick it up. This sounds fair for everyone, that everyone have the same opportunity to be picked up. But the problem is, after 3 days, you got a problem. Your oldest brother doesn't get picked up on 3 nights in a row. This is a problem. You may be thinking that your oldest brother is cheating on you guys. So you are going to have an assumption, or in academically you say that is hypothesis. Assume you have your oldest brother name is Gerald. This is Gerald, your oldest brother. And his name doesn't get picked up on 3 nights in a row. But let us make it positively. We assume that Gerald is picking randomly and not cheating. This is what we call as null hypothesis, or H sub 0. We are assuming that the other variables are not causing a difference. This is what we call as null hypothesis, or H sub 0, when we are assuming that other variables are not causing a difference. In this case, you are assuming that your oldest brother, Gerald, is picking randomly and not cheating. This is what we call null hypothesis, or H sub 0. As a statistician, of course, you going to calculate the probability of not getting picked. If it is one night, the probability of not getting picked in a night is 9/4, because you have four siblings, 1, 2, 3, 4, and except you, there are 3 siblings. So the probability of not getting picked in a night is 9/4. And a probability of not getting picked in 3 nights is 3/4 multiplied by 3/4 multiplied by 3/4, or we can say this is 3/4 to the third, which is we have this 27 over 64, and we have 0.42, and we can get 42%. This is 3/4 is 75%. So this is the probability of not getting picked in the night. If it is just one night, it is normal, because your oldest brother maybe doesn't get picked because the chance of not getting picked, which is 75%. And if it is 3 nights, it is normal too, because it is 42%. But the problem getting bigger when Gerald doesn't get picked up, his name doesn't get picked up on 12 nights in a row. This is a real problem, because he doesn't get picked up on 12 nights in a row. So let's calculate it. If it is one night, we have 25%. If it is 3 nights, we have 42%. This is normal because the chance of not getting peak is 42%. So probably if 3 nights he doesn't get peak, it is normal because the chance of not getting peak is big. This is can be considered as big. But if it is 12 nights, so we will have this 3/4 to the 12 equals to 0.032, which is 3%. This is low. Why this is low? Because the statistician somehow has stated the threshold of 8 sub 0 will be rejected is 5%. And because 3% is below than 5%, so the 8 sub 0 that stating Gerald is not cheating will be rejected. So because 3% is below than 5%, the threshold of 8 sub 0 will be rejected. So Gerald, the statement that stating Gerald is not cheating will be rejected. So that's why we're going to use the another kind of hypothesis. We will use H sub 1. So because of it, instead of saying Gerald is not cheating on 12 night, which is we use H sub 0, this is the first hypothesis. Hypothesis. We use this. We use the hypothesis that stating Gerald is cheating, which is H sub 1. So the conclusion of this, if Gerald is not be peak about 1 or 3 days, it is normal. It is normal, so we use H sub 0 because it is normal if he doesn't get peak only 1 or 3 days. But if he doesn't get peak, I mean, for 12 days, this is a problem, and we can use this hypothesis instead of this because the chance of he is cheating is bigger. So we use another hypothesis. The question, blah blah blah, is the threshold to discriminate significant from non-significant result inappropriately translated into existing from not existing difference or phenomena. Please choose one and state why. First, 50%. Second is 0.01. 0.05, I mean. The second question, with the illustration before, if Geralt doesn't get picked up in 5 nights to wash the dishes, he is cheating because the probability is below the threshold, which is 5%. So, is it true or false? And state why it is true and why it is false. Next, we are going to talk about validity of hypothesis by 5 methods. The first method is state null H sub 0 and alternate hypothesis H sub 1. First, we state the hypothesis to be tested. This is called the null hypothesis or H sub 0. H is for hypothesis and 0 implies no difference, just like what I explained before in the case of Gerald. This null hypothesis is a statement that is not rejected unless our sample convincingly proves that it is false. An alternate hypothesis is the conclusion you will be left with if you reject the null hypothesis, written as H sub 1, and also referred as research hypothesis. The second method is we select a level of significance. The level of significance is the probability of rejecting the null hypothesis when it is true. It is designed with the letter alpha. It is also sometimes referred to as the level of risk. There isn't one level of significance that is applied to all tests. A decision is made to use the level between 0 and 1, traditionally 0.05 or 5%, just like what we applied before. 0.05 or 5% is selected for consumer research project, 0.01 for equality assurance, and 0.10 for politic polling. The researcher must decide on selecting. The third method is we select a level of significance. The level of significance is the probability of rejecting the null hypothesis when it is true. It is designed with the letter alpha. It is also sometimes referred to as the level of risk. The next is there isn't one level of significance that is applied to all tests, just like what I explained before. This is what we going to do after we already use the hypothesis 1. Select the test statistic. Test statistic is a value determined from sample information used to determine whether to reject the null hypothesis. There are many test statistics such as first, z-test, second is t-test, third is independent t-test, fourth is paired t-test, and the last is ANOVA test. Z-test is a statistical test used to determine whether two population means are different when the variance are known and the sample size is large. What you need to know, what we call means here is mu, the average of the population. Then, when the variance are known and the sample size is large, in z-test, mean of the population is compared. The parameters used are population mean and population standard deviation. Z-test is used to validate a hypothesis that the sample drawn belong to the same population. The t-test, the mean of two given samples are compared. A t-test is used when the population parameters, mean, and the standard deviation are not known. Next is paired t-test. Test for the difference between two variables from the same population, pre and post test score. And this is independent t-test, meaning that the independent t-test, which is also called the two sample t-test or student t-test, is a statistical test that determines whether there is a statistically significant difference between the mean in two unrelated groups. And the last is ANOVA test. ANOVA is meaning analysis of variance that we call ANOVA. Is a statistical technique that is used to check if the means of two or more groups are significantly different from each other. The next method is formulate a decision rule. A decision rule is a statement of the specific condition under which the null hypothesis is rejected and not rejected. The region of rejection defines the location of all those values that are too large or small that the probability of their occurrence under a true null hypothesis is rather immune. Then the last method is we take a sample, arrive at a decision. The fifth and final step in hypothesis testing is computing the test statistic, comparing it to the critical value and making a decision to reject or not to reject the null hypothesis. Question: when do we use H sub 1 instead of H sub 0? In what condition we use H sub 1 instead of H sub 0?
on to the second part of the first topic. Testing for a population mean, known population standard deviation, we will be using a two-tailed test and a one-tailed test. An example, we show the details of the five-step hypothesis testing procedure. We also used to use two-tailed tests. That means that we are not concerned whether the sample results are larger or smaller than the proposed population mean. Rather, we are interested in whether they differ from the proposed value of the population mean. Jamestown Steel Company manufactures and assembles desks and other office equipment at several plants in western New York State. The weekly production of the Model A325 desk at the Fredonia plant follows a normal probability distribution with a mean of 200 and a standard deviation of 16. Recently, because of a market expansion, new production methods have been introduced and new employees hired. The Vice President of Manufacturing would like to investigate whether there has been a change in the weekly production of the Model A325 desk. Is the mean number of desks produced at the Fredonia plant different from the 200 at the 0.01 significance level? Let's find out. In this example, we know two important information. First, it's that the population of the weekly production follows the normal distribution. And second, the standard deviation of this normal distribution is 16 desks per week. So, it is appropriate to use the C statistics for this problem. We use the statistical hypothesis testing procedure to investigate whether the production rate has changed from 200 per week. Step 1. State the null hypothesis and the alternate hypothesis. The null hypothesis is the population mean is 200. The alternate hypothesis is the mean is different from 200, or the mean is not 200. These two hypotheses are written as H sub 0 is mu equals 200. H sub 1 is mu not equal to 200. This is a two-tailed test because the alternate hypothesis does not state a direction. In other words, it does not state whether the mean production is greater than 200 or less than 200. The Vice President wants to find out whether the production rate is different from 200. Step 2. Select the level of significance. As we indicated in the problem, the significance level is 0.01. This is the probability committing a type 1 error, and it is the probability of rejecting a true null hypothesis. Step 3 is to select the test statistics. The test statistic Z is when the population standard deviation is known. Transforming the production data to standard units of Z values permits their use not only in this problem, but also in the other hypothesis testing problems. Formula from 10.1 for Z is repeated below with the various letters identified. Step 4. Formulate the decision rule. The decision rule is formulated by finding the critical values of Z from Appendix B1. Since this is a two-tailed test, half of 0.01 or 0.005 is placed in each tail. The area where H sub 0 is not rejected is located between the two tails. It is therefore 0.99. Appendix B1 is based on half of the area under the curve, or 0.5000. Then 0.5000, 0.0050 is 0.4950. So 0.4950 is the area between 0 and the critical value. We locate 0.4950 in the body of the table. The value nearest to 0.4950 is 0.4951. Then read the critical value in the row of column corresponding to 0.4951. It is 2.58. For your convenience, areas under the normal curve is repeated inside the back cover. The decision rule is therefore reject the null hypothesis and accept the alternate hypothesis, which states that the population mean is not 200. If the computed value of Z is not between minus 2.58 and plus minus 2.58, Do not reject the null hypothesis if z falls between minus 2.58 and plus minus 2.58. Step 5, we make a decision and interpret the result. Take a sample from the population, compute z, apply the decision rule, and arrive at a decision to reject h sub 0 or to not reject h sub 0. The mean number of deaths produced last year, 50 weeks because the plant was shut down for 2 weeks for vacation, is 203.5. The standard deviation of the population is 16 deaths per week, and the formula is written as below. Because 1.55 does not fall in the rejection region, h sub 0 is not rejected. We conclude that the population mean is not different from 200. So we would report to the Vice President of Manufacturing that the sample evidence does not show that the production rate at the Fredonia plant has changed from 200 per week. The difference of 3.5 units between the historical weekly production rate and that last year can reasonably be attributed to sampling error. This information is summarized in the following chart. Now for the one-tailed test. A one-tailed test is a statistical test in which the critical area of distribution is one-sided, so that it is either greater than or less than a certain value, but not both. If the sample being tested falls in the one-sided critical area, the alternative hypothesis will be accepted instead of the null hypothesis. For this, we will reuse the question from above. We emphasize that we are concerned with reporting to the Vice President whether there had been a change in the mean numbers of desks assembled at the Fredonia plant. We were not concerned with whether the change was an increase or a decrease to the production. So we changed the problem. Suppose that the Vice President wants to know whether there has been an increase in the number of units assembled. We can conclude because the improved production methods that the mean number of desks assembled in the last 50 weeks was more than 200. The biggest difference here occurs in the alternate hypothesis. Before, we stated that the hypothesis is a different form. Now we want to state that it is greater than in symbols. Whereas a two-tailed test has h sub 0 mu is equal to 100 and h sub 1 mu is not equal to 100, a one-tailed test would have h sub 0 is mu less than 200 and h sub 1 is u more than 200. The critical values for a one-tailed test are different from the two-tailed test at the same significance level. In the previous example, we split the significance level in half and put half in the lower tail and half in the upper tail. In a one-tailed test, we put all the rejection region in one tail. For the one-tailed test, the critical value is 2.33, found by first subtracting 0.01 from 0.5000, and second, finding the z value corresponding to 0.4900. Now we've moved on to the p-value in hypothesis testing. In testing a hypothesis, we compare the test statistic to a critical value. A decision is made to either reject the null hypothesis or to not reject it. This process compares to the probability called the p-value, which is the significance level. If the p-value is smaller than the significance level, h sub 0 is rejected. If it is larger than the significance level, h sub 0 is not rejected. So, for example, if the critical value is 1.96 and the computed value of the test statistics is 2.19, the decision is to reject the null hypothesis. In recent years, spurred by the availability of computer software, additional information is often reported on the strength of the rejection or acceptance. That is, how confident are we in rejecting the null hypothesis? This approach reports on the probability, assuming that the null hypothesis is true, of getting a value of the test statistics at least as extreme as the value actually obtained. In summary, The p-value is the probability of observing a sample value as extreme as or more extreme than the value observed, given that the null hypothesis is true. Now, what does it mean if the p-value is small? Now we're moving on to how we compute the p-value. The null hypothesis at the mean number of tests produced per week at Fredonia was 200. We did not reject the null hypothesis because the z-value of 1.55 fell in the region between 2.58 and 2.58. We agree not to reject the null hypothesis if the computed value of z fell in this region. The probability of finding a value of 1.55 or more is 0.0606, found by 0.5000, 0.5394. To put it another way, the probability of obtaining a greater than 200 and 0.5 if 200 is 0.0606. To compute the p-value, we need to be concerned with this region less than 1.55, as well as the value greater than 1.55, because the rejection region is in both tails. The two-tailed p-value is 0.1212, found by 2 multiplied by 0.0606. The p-value of 0.1212 is greater than the significance of 0.01, decided upon initially, so h sub 0 is not rejected. The details are shown in the following graph. In general, the area is doubled in a two-sided test. Then the p-value can easily be compared with the significance level. The same decision rule is used as in the one-sided test. A p-value is a way to express the likelihood that h sub 0 is false. But how do we interpret a p-value? We have already said that if the p-value is less than the significance level, then we reject h sub 0. If it is greater than the significance level, then we do not reject h sub 0. Also, if the p-value is likely very large, then it is likely that h sub 0 is true. If the p-value is small, then it is likely that h sub 0 is not true. The following box will help to interpret p-values. H sub 0 if the p-value is less than a 0.10, we have some evidence that the h sub 0 is not true. B 0.05, we have strong evidence that the h sub 0 is not true. C 0.01, we have very strong evidence that the h sub 0 is not true. D 0.001, we have extremely strong evidence that the h sub 0 is not true. In the preceding examples, we knew omega, the population standard deviation, and the population followed the normal distribution. In most cases, however, the population standard deviation is unknown. Thus, omega must be based on a prior study or estimated by the sample standard deviation of S. The population standard deviation in the following example is not known. So, the sample standard deviation is used to estimate omega. To find the value of the test statistics, we use the t-distribution and revise the formula as follows. T equals x subtracted by mu divided by s divided by n root, with n subtracted by 1 degrees of freedom where x is the sample mean, mu is the hypothesized population mean, s is the sample standard deviation, and n is the number of observations in the sample. Question. There are 5 major characteristics of the t-distribution. What are they?